Hello guys, in this video tutorial we are going to create the detailed drawing for this particular mechanical component. It is a connector, and as you can see it has lot of features here. So to create the detailed drawing we need to orient this component in such a manner that we can see most of the feature. So in this front view we can see most of the features of this particular component. To create the detailed drawing I am using Solidworks. For that, let's proceed. Let's go to file, click on make drawing from part. So here we have to select the type of sheet. So right now I'm going to select A3 landscape, ANSI standard sheet, and click on OK. So here I have the sheet, and on the right side I have the view palette, and on the bottom I have the current view. So just drag and drop the view over to the sheet, click on OK, and here we have this view, but we need to enlarge the view. For that, let's change the scale. Let's go down, use custom scale, and let's make it to 1:1. So now the view looks good. Okay, so here we have the view. As we know that the connector is cylindrical in form, so we need to create the center line about the axis. So for that, in annotation we'll see center line. So let's select the edges like such, click on OK, and here you can extend the center line manually. Okay, now we need to define the dimensions. For that, let us first of all go to sketch, select point, and create a point over here, because here we have a circular edge, and it will be difficult to trace the point over here for the placement of the dimension. So now let's make some dimensions for this particular component, starting with the total length. Let's select smart dimension, select this edge. One thing more, I need to change the units to millimeters. Let's refresh the view palette. Okay, so now again smart dimension, select the edge and this point and place the dimension upwards. Okay, now for this particular section I need to place the length also. So again the starting edge and this point, and let's place the dimension upwards, click on OK. So here we have the dimension. Here we have a threaded surface, so again the two edges we'll choose and we'll place the dimension. Now again here, same way here. Okay, we have this one also, this section. Let's place it at the bottom. Okay, for this section I'm not considering to place the length for this particular shoulder, because it does not play any major role in this component. So I'm not placing the length for this particular section, but the length for this section, it is significant to us because it has a feature over here. It has a slot over here and also a hole. If you will see from the side view, it has a hole inside, and we will see this hole later on in this tutorial. Okay, so we have just placed the length for this particular section. So we are done with the lengths. Now let's start with the diameters of each section. For that, again smart dimension, here let's select both of the edges. Now after placing this dimension, we need to place the dimension for this threaded surface. Again smart dimension, select both of the edges and place it. For this particular section, I would like to share that this is a threaded part, and it has M20 thread having a pitch of 1.25. so we need to make modifications for this particular dimension. Select this dimension, go to dimension text and just delete this dimension, click on yes, and now we need to insert the text, that is M20 into 1.25, the pitch of this threaded surface. Okay, so here we have the pitch. And now going on forward, we have here, it is basically a square section. So how to describe the square section in 2D? That is, we need two cross lines. So here we have one line and one more. So in this way we can describe that this section is basically not a cylindrical section but a square or rectangular section. Okay, so this is done. Now going on forward, here we have a conus section. So let us describe the dimensions for this. So in this case I would like to consider this diameter. So here we have this diameter, so let's place it over here, and here we have an angle. So let's define the angle for this particular conus. So that is 8 degrees basically. Click on OK. Now going on forward, again we have this shoulder. Define both the edges and let it be here. For the moment I'm just placing the dimensions, and later on I will make the arrangements and make the dimensions look more clear and tidy. Again, now for this section, the diameter is this one, that is 50 mm. Okay, so I think we are done with the diameters. Okay, now let's place them in a neat and tidy manner. One thing more, I need to define the cross section of this section. The dimension for this cross section, that is 26. The side of this squared shape section is 26, so I need to describe it. So let's select the dimension, and here you have to place this sign over here, this square, that means a square section. Okay, now going on forward, here we have this diameter 50, that is nicely placed. Now this one we can place it over here. Okay, now this one is also let it be here. I think it will be here. Okay, now next, this is nicely placed. So the diameters are nicely placed, and the lengths are also placed accordingly. Now let's go to drawing and let's select the, we have broken out section and we need to break out this section. Now let's define the chamfers. Now after placing the diameters, now let's define the chamfers. So again, annotation smart dimension, let's define the chamfer value. Okay, here also we have one chamfer. So here in this case we have 4 into 45 degrees the chamfer size, and here is 2 into 45 degrees also the size of the chamfer. So this chamfer and this chamfer, they are same basically, and I have defined the size of this particular section. Now this one 1.84 into 45 degrees. Now after placing the chamfer values, Now let's one thing more, I should define the radius for this particular edge also. So again, smart dimension, and here we have to select this surface and let's place it over here. Select the dimension, and in the leaders you will see custom text position. Just select the middle one. So here we have this radius for this surface over here. And one thing more, I need to specify the center mark for this particular section, and also for the slots also I need this center mark and need to change the orientation, and it's okay now. Okay, this is done. Now one thing more, I need to describe this length also. I need to describe it. So I need to define this length. So it is approx 10 mm. So now most of the features are done. Now let's define this undercut for this threaded surface. So for that we need to create a detail view. So let's create a detail view for this particular edge or the corner. So let's make it 1:1 or maybe 5:1. So I think 5:1 will be enough. So here we have this section, detail view for this undercut. We need to create the leader. So here we have the leader. Okay, so leader is done. Now in this we need to specify each and every dimension. So let's start again with annotation smart dimension, and I need to first of all specify the depth of this undercut, that is 1.8. okay, now let's specify the inside diameter for this undercut. So let's select this edge, and here we go. Also this one, here we go. But as you can see here, we are missing the diameter sign. So let's insert the diameter sign. Okay, so this is done. Now let's define the width of this undercut. Let's select the edges and this one also. So it should be 5.5 maximum value. Delete this 5.5. That should be the maximum value for this particular undercut. Now again smart dimension, and we need to define the two radius value we have in this undercut. Okay, using control from your keyboard, just drag and drop the edge of this arrow and create a multi leader. So to define both of the filters, both of the fillets in this undercut. So we are done with the width, the radiuses, the depth. Okay, so I think we are done with the detail A, that is undercut in this component. Okay, next we have this shoulder over here, and we have some specifications for this particular shoulder. We need to show the knurling over here. For that, again, let's go to sketch and let's select a corner rectangle. Let's create a rectangle over here. Basically we are going to show knurling over here using the hatch tool in SolidWorks. So here we have a rectangle, and now for the hatch we have to choose annotation, and here we have area hatch fill. Now you have to select the parallel lines hatch over here. Just write P from the keyboard. Here we have parallel lines, and just select the inner area of this rectangle, and here we have this hatch. Okay, just click on OK. So here we have this nulling, and now we need to describe the type of nulling which is to be done. So note and place it here and write the text null RGE 1.2, and the standard for this null is ISO 3403. Okay, now one thing more, let's change the orientation of this leader. So select the text, and here we have this leader, underline leader. So check it. Okay, so now it look nice. So we are done with the text. Now also we have a slot over here and a hole inside, tapered hole, sorry, tabbed hole inside. So after describing the nulling, also I need to describe this slot. I forgot to describe the length of this slot. So let's define this smart dimension and select both of the semicircles and place the dimension. So here we have 12 mm, that is the length of this slot. And now let's describe the radius. Okay, so let's place it over here, maybe, or maybe here, leaders, custom text position, and like this. So we are done with the slot also, but we need to define the depth of this slot. For that, I should create a section. Okay, so let's create a section over here. For that, let's go to drawing, and we have a section view over here, and let's create a section. Okay, so let it be here. So here we have the section. Now let's make some adjustments accordingly. Okay, and one thing more, I should also describe the distance of this slot from the edge. So again, smart dimension, select this edge and let's place the dimension over here. So okay, now it looks complete. Okay, so we have this section over here. Here we can define the depth of this particular slot. For that, let's go to sketch and select point, and now create a point over here. Now to describe the depth of this slot, go to smart dimension and select this surface and this point over here and mark it. So we have this dimension over here for this particular. So with the help of this dimension, we can define the depth of this slot. Let's define some tolerance value for this also. Let's go with bilateral, and here let's make it okay. So here we have some tolerance values added to this dimension, so this is clear. So now let's create one more view for the hole, to display the hole. Again, let's go to drawing, and let's go to projected view. Just bring it over here. Now we have this hole over here inside. So let's go to drawing, and again we need broke out section. So let's draw this broken out section. And now we need to define the depth. So the depth will be this one, 80 divided by 2, that is 40. It is the diameter, the maximum diameter, and we should divide it by 2 to get the broken out section at the middle of this particular component. So it will be 80 divided by 2, that is 40. Click on preview. So here we have this hole. Click on OK. So as you can see, here we have this hole inside. Now again we need to go to annotation, and here we have the center line. Now let's mark the center line for this hole. So here we have this hole. Just drag and drop it a little bit. So now let's mention the details for this particular hole. First of all, let's define this diameter, that is 25, and the depth, it is 2 mm. Now this is the threaded part, so we have to define the length of the threaded part, that is 23 mm. Okay, let's change the leaders to be inside. Okay, now let's define the threads, smart dimension, and here we have the threads. So that is M20 threads, and the pitch is 2.5. You can place it over here. Okay, now also I need to define the total length of this hole. So again, smart dimension, and let's select the edge, so that is 35. So I think I'm done with this. Okay, so let's check again that nothing is left behind. So most of the things are done except for the surface finish. So we need to define the surface finish for this component. So the main mating part for this particular component is this section. So here we are going to link this particular section to the gearbox. So for that we need to define the surface finish also, and also I forgot to define the tolerance value for this section. So let's define this. Let's select the value of the diameter, go to tolerance, fit with tolerance, and here we have this clear tolerance. Here it is sharp, so for this case we have the F7 tolerance, so it is defined. Let's place it back. So the tolerance value has been specified. So now let's define the surface finish for the component for this section particularly. So for that, annotation, surface finish, and here I'm going to use a leader. So here we have this leader, and here I can place it in such way. So here we have the surface finish sign, and I want it to be fine, so that is 0.8, the surface finish for this particular section over here. So after placing the surface finish sign, I think the drawing is done. We are done with the drawing, with this detailed drawing for this connector. Okay, I hope you understood the principle of making the detailed drawing for this mechanical component. So now we are going to end this video. If you like this video, please like, share and subscribe. Thank you for watching.